So this is CPM Calculus Chapter 2, number 55. So here we have the function sine of x. Okay, so it starts at 0, 0, goes up, down, up, down, up, down. But now we have just one region from 0 to pi. Okay, so that's 0 and that's pi. And we want to estimate the area between 0 and pi. So this area using 6 midpoint rectangles of equal width. Okay. So part A is to estimate the area. So let me do that. Our function from 0 to x less than pi. Okay. So when we're estimating, remember to always use squiggly equal signs because it's an estimate, approximately. So what is this base? Okay, so we're going from 0 to pi, and we have 1, 2, 3, 4, 5, 6 rectangles. So the base is always, so we're going to basically, let me step back. It's basically base times height plus, okay, base times height 1 plus base times height 2 plus base times height 3 plus base times height 4. So each of these is the area of a rectangle plus base times height 5 plus base times height 6. Okay, and that base we know is equal to pi over 6. Okay, because we divide pi into 6 regions, so each one is going to be pi over 6 in length. Pi over 6, pi over 6, pi over 6, pi over 6, pi over 6. Okay, so then we have approximately pi over 6, and then we could take that out, and then we're just adding h1 plus h2 plus h3 plus h4 plus h5 plus h6. Okay, so what are all these heights? Well, this height is at where? It's right here between 0 and pi over 6. So you can figure that out. Pi over 6 minus 0 divided by 2. Okay? So that is equal to pi over 6 divided by 2, which is equal to pi over 6 times 1/2, which is pi over 12. So that's equal to pi over 6 times h1 we know is sine of pi over 12. Sine pi over 12 plus h2. So now we just want to add pi over, so the distance between this midpoint here and this midpoint here is just pi, the distance between them is pi over 6 because we're just going pi over 6, 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 right? So pi over 12 plus pi over 6 is equal to pi over 12 plus, multiply by 2 on top and bottom, 2 pi over 12, which is 3 pi over 12. Okay, so let's keep that as, we could reduce that to pi over 4, but if we keep it as 3 pi over 12, they will all look alike. So sine 3 pi over 12 plus sine, so we're just adding pi over 6, so it's going to be 5 pi over 12 plus sine 7 pi over 12. So that's h1, h2, h3, h4. h5 is sine 9 pi over 12. And h6 is sine 11 pi over 12. Okay? So we add these all up. Is there a smarter way we could do this? Well, we could just put this all in our calculator. Or we could use our sigma notation. Where are we starting? Well, we're multiplying pi over 6 times sine. And what are we doing? Remember, we're just taking pi over 6. Pi over 12 plus pi over 6 times I, or some variable. Let's call it something else. Times k. I don't like to use I because I use cursive and it looks like imaginary. So k starts at 0 and it goes from 0, 1, 2, 3, 4, 5. From 0 to 5. And that makes sense because we have 6 rectangles. So 0 to 5 is good. So use our calculator, we could put this in. Okay, let me just enter it in. Make sure I'm in radian mode, which I am. So my expression is going to be pi divided by 6 times sine of pi divided by 12 plus pi divided by 6 times k. My variable is k. I start from 0, I go to 5. So I put that in my calculator, and I get a big answer, okay? Because it's giving me the exact value. So I can even put that here. I get that is equal to, since we're approximating, so I want to use approximate, square root of 3 plus 1 times pi square root of 2 over 6. So if you did this, you should get something similar. And I put approximate, and I get 2.023 something something something. So my approximate area is 2.02303, but I'm going to just keep it with 3 digits after the decimal place. And because I'm looking at the area, I say units squared. So that's my answer for part A. Okay? So let's move on to part B. So part B is saying, well, what if all of this region, right, is going to be, if the region defined by the area here is rotated about the x-axis, then each of these rectangles will become what shape? So if we're going to rotate them around the x-axis, we're just going to have, like, what do we have? We're going to have basic, oh, I cannot draw. Let me try that again. We're going to have, so this has a thickness around it, and this has, we're rotating it around, right? We're going to make cylinders. We're not looking at our sign, we're looking at each rectangle. We're going to have 1 cylinder, 2 cylinders, 3 cylinders, 4 cylinders, 5 cylinders, 6 cylinders, right? And these 2 cylinders are equal in volume. These 2 will be equal in volume, and these 2 will be equal in volume. Okay? So each of these rectangles becomes what shape? They become cylinders. C-Y-L-I-N-D-E-R-S. Is that how you spell cylinder? Sometimes I forget if it's A or R, or E. Anyway, sketch a picture representing this situation. Oh, I'm really bad at sketching, but basically we have a cylinder, another cylinder, another cylinder, right? Another one, same size as that one, another one, same size as the one before it, and one more. Okay, I'm trying to make it 3D, so it's kind of like looking like that in the middle. But there you go. They become cylinders. Here's my sketch. Okay. Part C. Estimate the volume of this rotated region by calculating the volume of each of the rotated rectangles. Okay, so we know the volume of a cylinder. Volume of C-Y-L-I-N-D-E-R. If you don't know what it is, you could have looked it up. But it's basically going to be the area of, so a cylinder, if you look at it, right? If you look at it like this direction, oh man, I really cannot draw. Okay, if you look at it like this, it's like a drum. This thing right here on top is a circle, and the bottom is a circle too. We know the area of a circle, right, is pi r squared. So if we multiply the area times the height here, we get the volume of the cylinder. I was running here, so it's going to be pi r squared times the height. Okay, so each one of these is going to have a different, well, the height for each of these is the same. So the height, when we look at it, so we could say h is just, remember, pi over 6, because the distance between here is pi, because this right here is pi, that's 0, divided by 6, equal rectangles. So the height is pi over 6. Now, the radius is basically what we calculated earlier, is going to be the height or the value of sine at the midpoint. Okay, so it's going to be this, the height of this rectangle. I'm using height in different ways because the height of the cylinder is going to be the distance from bottom to top of that circle. So it's kind of like the base of the rectangle, and then the height of the rectangle is going to be our radius. Okay, so how many radiuses do we have? Well, like I said, these two are the same, these two are the same, these two are the same. So let's just do it 3 times, 1, 2, 3, and then multiply that by 2. Okay, that'll save us some time. So the volume of the cylinder is going to be, the volume of all the cylinders, so I'm going to put plural, is going to be the sum of the volume of one cylinder. Okay, so I'm just going to use that notation loosely, and we know it's going to be pi times r squared. So what's the first r? The first r is, remember, pi over 12 is this point, so it's going to be sine of pi over 12, right? So it's going to be pi times sine of pi over 12 squared times h, which is pi over 6, plus our next cylinder is going to be pi times sine of pi over 12 plus pi over 6 times pi over 6, right? So this right here is the distance from 0 to here, so it's going to be, if we plug in sine, it's going to give us this height, okay, plus pi, I'm just pulling out pi r squared h, oops, I forgot to square this one, pi r now is going to be this height, so it's going to be sine pi over 12 plus pi over 6 plus pi over 6, right, to get to here, squared times pi over 6, okay? And remember, I want to multiply all this by 2 because we're doing the little time saver, because when we get these 3 volumes, that's going to be the same as these 3. Okay, so we can do this in summation notation, but this time I want to just do it out. So I'm going to do 2 times, use my calculator, sine pi divided by 12. Okay, this is going to take a while to put in the calculator. So I want to do the summation notation again, because I'm all about saving some time. So what does that look like? That's going to look like we still have 2 times whatever it is. We can even factor out the pi and the pi over 6, which are in each of these. See pi, pi over 6, pi, pi over 6, pi, pi over 6. And we're then going to be adding what? Sine pi over 12 plus pi over 6 k, right? This thing we need to square. We're squaring it each time. Starting at 0, 1, 2. We're ending at 2. Okay? And this can stay on the outside, or it can be moved in. It doesn't matter. Okay? Because multiplication can move in the summation or outside. It doesn't matter again. So I'm going to leave it outside. 2 pi times pi squared over 6. This is going to reduce to pi squared over 3 later. But now I'm going to put this in my calculator right here. Okay, so I'm going to do the sigma notation. So I go into catalog. Catalog sum. Okay, the expression is going to be sine pi over 12 plus pi divided by 6 times k, and I want to square that. So it's going to look, I'm going to write it out what I put in my calculator. Okay, squared. So what I'm putting in is sum sign, opens parentheses, I start with another parentheses, sine pi over 12 plus pi over 6 times k. You can use x here. Close it again, because now I have this whole sign. I square it. Okay? So then I put comma k, or if you used x there, you put x here, and then I go from 0 to 2. 0 to 2. And I'm just writing it like that because that's how I'm plugging in the calculator. This parentheses closes this one. I equal it, and I get 3/2. So I get 2 pi squared over 6. Oops, let me undo that, because I just said that 2 over 6 becomes 1 over 3. So pi squared over 3 times this whole thing becomes 3/2. So that's equal to, these 3's cancel out, pi squared over 2. Okay, now that's what our volume equals exactly of the cylinders when you add them up. So approximately, just put in your calculator pi squared divided by 2, and then use the approximate symbol, and I get 4.9348. So that 8 makes this next one a 5 units cubed. So this is important for volume. Okay, so the cylinders make a volume of 4.935 units. Okay, so this concludes Chapter 2, number 55 of CPM Calculus.